Welcome, and I will be starting shortly. Welcome to Microcontrollers with kingernorth. This is episode 15, OLED displays with CircuitPython and Arduino. And good morning to you too, Walter. I see that you're in there right on time as usual. All right, so let's get started today. We're going to keep a watch on those dropped frames to make sure we don't go garbly on our audio. Hopefully it'll stay nice and clean today. Now that I'm watching it, it'll probably be fine. So there we go. So let's get into our look at the devices we're going to be playing with today, and let's talk about them. So here we go. This is the items that we're using today. So we have a couple of OLED screens. OLED is an organic LED, and these are becoming very, very popular. There's a lot of advantages to these. The biggest thing is that they have high resolution, or fairly high resolution. They typically are very low power consumption wise, so they're actually very economical to run. They don't require a backlight since they are their own light source. So those are the advantages. We actually see them on a lot of our devices today, little coffee makers, things like that. We used to see a lot of LCD screens, and they've been switching over to OLEDs. One, they're a lot smaller, which is good and bad. And the second is that they're just easier to work with. You don't have to worry about a backlight and things like that. And then without the backlight, it really makes them handy. I have one running each right now, one on the Arduino and one on the Feather M4 Express. And both of them are running a little bit different code. And you can see that we can do animation, we can draw things with them, we can do text. There's a number of things, and we're going to go through that in a lot more detail. But before I get into that, I'm going to talk about a couple of the different sizes and what we should be looking for when we're looking for OLEDs. Because there are pitfalls when it comes to this stuff too. So right now, the two that are running, this one here and this one here, are both 128 bits across. Now they're sideways to you right now, up and down. So that's 128 bits of light this way. But then this way, there's 64 bits. So this is a 128 by 64 screen, and that's what this is, this OLED, which is still relatively small, and you can tell by the size of my finger that is a fairly small screen. But they do get smaller, like this one here, or this one here, and in fact, they both have the same screen on them. This is 128 across, just like the other one, but it's only 28 rows of lights. So you're not going to be able to put as much text or graphics on that same amount of real estate, because you only have half the real estate. And then these ones here are larger. But if you notice, I have different ones here. In fact, they have their little protection screen on them that comes on that you peel off once you get them. And this one has a red tab. This one has a blue tab. This one also has a blue tab. But they're actually all different from each other. And I want to show you some of the pitfalls you're going to work with. These all work with I2C. Now, we talked about that early on in the shows, probably somewhere around episode 4 or 5. We looked at I2C as a communication protocol, which makes it easy to hook up because there's only 2 wires that go back to the actual microcontroller, and then 2 for power and ground. So they're pretty simple to wire up, but I'm going to show you some of the pitfalls. Is that they come in different styles. For the Circuit Playground Express, they make this one called a feather wing. Now this one with a feather wing, it has lots of pins on it. This is a feather. This is made by Adafruit along with the M4, the Feather M4 Express. But this one here actually has the exact same format So if you use stacking headers, you can actually put this one right on top of the other one. You could actually have them sitting so they don't take up any more footprint. And it also has 3 buttons to allow you to interface with it built into the board. So they're already pre-wired into the board, and you can access those as well as the screen. So that's an advantage. You pay a little premium for that because after all, it is made onto a board. It is assembled except for the header pins, because you can put your own choice of style of header pins on there. But so that one's a little bit of a choice. This one here is nice and small. Everything is built into there. There's actually the I2C chip and everything is all on this thing. Everything is programmed into this, ready to go. Now, let's move this one out of the way. And let's move this tiny little one out of the way. Let's have a look at these 3 because they are all different. They look similar, but they're not. And that's where the similarity ends, is they look the same to the user on the front end. These 2 both work. In fact, the one with the blue tab here, this is the one I'm using. I'm using ones that are identical to it in both of these applications here. Now these, if you flip them over, we can see on the back, and in fact, let me just zoom in a bit here so we can really get a good look at that. And we'll just move them accordingly. We can see that there's addresses on the back. The address is already listed there. It's IIC or I2C, address select. Now it says that it's 0x78, and there's a little resistor that jumps across that gap, or you put it across the other gap, you unsolder it and move it over, and it should be 0x7A. The problem is, that's not the address. So back when I did the scanning, when I did I2C, I showed you a scanner program, so you could scan I2C addresses for devices. When you scan this particular board, you'll find out that the address is not 0x78, it's actually 0x3C. And if you move the jumper over, it becomes 0x3D. So why it's stamped like that on the back, I'm not 100% sure. They may have originally created these boards and then later on they decided to use a different address and they never bothered to recreate the boards. They just kept using them, probably because they already had them made. But you need to scan all your I2C devices so that you find out what the actual address is so you don't run into this problem. Very, very important to come across. Now, one other little change. On the front of this board, when I look at it, it starts here on the left with ground, then V in, that's your voltage in. Now this board will work both on 3 volts and 5 volts, so it's interchangeable. It's got an SCL and an SDA, which are your 2 communication channels for your I2C. Compare it to this one. This one starts with VCC, so that's your power, then your ground, then your SCL and SDA. So the ground and the power pin, this one 5 volt, again, it usually works on 3 volt as well. Most OLEDs will work on both. You find that these 2 pins are reversed. They actually put positive on the outside edge and they put ground on the inside edge, but the 2 communication lines are still the same. So when you wire these up, you've got to be sure of your connections. Don't wire them backwards, they won't work. So just something to consider when you're playing with these things is that they're not all created equal. I got these at different times. And if that wasn't confusing enough, let's move this one up out here, out of the way. I'll move this one over here, this one over here, and I'm going to bring this one in. Now this one here shows me VCC, ground, SCL, SDA. So it matches the other blue board here. The problem is when I flip it over, and I flip this one over, they are very different on the back. This one doesn't give me any addresses. This one here. It doesn't have the extra chips up here. And it has maybe extra parts in here, I'm not sure, but there's a bunch of resistors and capacitors. You can tell that by these are labeled C and R. So those are resistors and capacitors to make it work properly. This one, when I scan it, there is no address. There's no way to change an address. There's no jumpers to change. Usually these are selectable. I'm not able to get this one to work. So I bought these quite a while back, put them in my stock, and eventually went to go use them, and I couldn't get them to work. And I played around and played around and played around, and I tried using the default addresses of 0x78. Then I tried 0x3C. and nothing seemed to work. I tried scanning them, I couldn't read them. So what these are good for right now, these are spare screens for me if something happens and gets damaged on these. Then I'll peel this off and I'll resolder it on and I'll switch it out with this one to save it. These are relatively cheap. You can buy these through eBay, AliExpress, and they tend to work with most of your microcontrollers. They're really relatively cheap. In fact, I think I got this last batch of them, which are these ones here, the ones I'm using today. And I think I picked them up for a little over $1 a piece. And I think these ones came out of eBay, so they were probably around $2, $3 a piece. And that was probably the same, and then I found out that they didn't work. So that's the chances you take sometimes when you're dealing with eBay and places like that, or Amazon or AliExpress. You may not get what you're thinking you're going to get. And I didn't check them right away, so there was no recourse going back and trying to get the right item, that they sent me the wrong item or something like that. I only bought 2 of them, thank goodness for that, but they don't work. At least not yet, until I could figure out what to do with them. So be careful of that. So this is the I2C. So this is something you should be aware of. Now, I was saying these are small. Let's get these 2 out of the way. Let's compare them in size. We did a program where we did the LCD display. Look how much bigger that display is. That display is huge compared to here, but it's much less resolution on this screen. This was 16 characters by 2 rows, which is a pretty standard LCD. Physically, it's a lot bigger, which means the letters are probably easier to read because it's big, but they're very limited graphic patterns as well. I believe they were like a 5x7 graphic, things like that, which is still pretty small. It's only 5 dots by 7 dots each character. And they're all spaced out and there's an empty space between each one. So your limited graphics you can do with one of these. This is very limited. This one has more versatility. It's a much finer resolution, but it is way smaller. So you have to think of your audience and your application, decide which is best for you. If power's not the concern and you want the bigger print, this is probably the one you use. I use a couple of these on my train layout. I'm going to be using a couple of these, and I'll show you why when we get into our samples today when I run my program. And you'll see why I want to use this one, because it's much, much cleaner to look at and much easier on the eyes. Both work. These are definitely cheaper. These are a little more expensive. These here have the addition that you have to add the I2C driver board to them. This is already built in. So by the time you add both parts here, you're probably looking, even on eBay, you're looking at $5 or $6 a piece. This here, you're still looking at $2 to $3. And they're very, very lightweight and take up very little power. Still convenient. So the choices are yours. So now that we've done that, let's go into our main screen. And I'm going to move these out of the way. We don't need these ones anymore. And I'm going to move my Circuit Playground version out. And I'm going to hopefully bring this in like this. And in fact, I'll zoom out for a moment. There you can see the board. We're using the standard Arduino. In fact, I'll turn it this way just to show you the start. And I want to show you how these are wired up, because I actually have drawings for both of these. So let's talk about that for a moment. So here's your image. This is your wiring. It's pretty straightforward what I've done on the board here. This is your, let me get the picture up here. There we go. There's my cursor on the screen now. So this is the OLED up here. And the OLED has the 4 connections on it. And I've wired them up. Now you can actually read those if you really want to. They're a little blurry. These images are rather small, but this is in fritzing. I created these. These are just in fritzing. I created this drawing yesterday, just to show you how it's connected. So I take my power, my 5 volts, and my ground connection from my Uno and connect it to my board. I go ahead and connect them to the device. And then what I do is for I2C on Arduino, I take these 2 from here and I connect them to A4 and A5. Those are the same as if your board has these 2 connected underneath. You might read it on the bottom of the board and it might say SCL and SDA, and then you could hook them up there as well. The other thing I've added to this board, because we're going to use it for our example today when we're writing our code, is I've included a 10,000 ohm pot here, one of our potentiometers, and I'll be using that in. So I'm bringing that into my analog 0 in, And again, I just hooked it up with power and ground so I can send a voltage reference back to the analog pin. And like I said, we'll be using this within the program today. The CircuitPython version, this is the Feather M4 Express. So this is their board here mounted on the board. And again, I just bring in the voltage. Now this is 3 volts. So this is fed from the board. Now this is feeding this board, exact same OLED screen as I'm using in the other one. And again, I've taken these 2 communication wires, SCL and SDA, and I've connected them to the appropriate ports. Now those are marked SCL and SDA on the board, so they're easy to connect. And that's my communications connection. So very, very simple connections on here. Not hard to connect an OLED at all. So you can utilize that, and it makes it really, really easy to work with. All right, so let's have a look at some sample code that we're using here. Okay, I got to find my mouse again. There's my mouse. It's back. Okay, so I got to switch screens, so I'm going to turn that off, and I'm going to turn on my Arduino program. But I want to show you something here, and I'm going to turn this way. We don't need to see the whole board. We just need to see this portion of it. And I'm going to zoom in. So I'll just get over here to the zoom control. So we can see the screen. See exactly what we're doing here. Those are those connections. All the wires are connected just exactly how I showed them in the diagram. So this is my screen here. So all I'm going to do is I'm going to hit the reset button on here. And this has just got a sample program running on it that comes right off of the Arduino software. And this is using the Adafruit driver. And you can see we can still do some graphics on here. It's not perfect graphics, but you can see it works. It drew some. It's drawing boxes. We can actually watch it go through that animation. I can show you that code if we've got enough time at the end. But it's all just done really quickly. I should almost lock that focus in at this point. It wants to jump around. Let's see if it catches up here. Okay, that focus should stay. And then what we have here is we just have some graphics. This is the Adafruit logo going by. It actually referred to as snowflake. So that should just keep going by, and that'll just keep playing now forever and ever until I reset it again. So that's how that works. But what I'm going to do is I'm going to show you how to create some simple text on it and how to set this thing up. So we're going to utilize this program right here. We're going to start with an empty file just like we normally do. And I'm going to come in here. So the first thing we want to do is we want to put in a title for this here. So I'm just going to go up here and I'm going to call it I'm just going to call it an OLED test. So we're just going to write some simple Arduino code. And we're not going to do here, and this is just simply a simple test for a 128 by 64 OLED display. So that just tells us what we're doing in here. So it's very simple. And before we go any further here, I just want to save it because I want to give it this name, OLED test. So I'm going to go File, Save As. It's actually going to give me this choice up here. Well, I'm not going to put it in that library. So let's go up. We're going to go down to our electronics show. Yeah, look at how many we've done. So I2C was actually done on episode 9 if you're looking for it. So that's in there now. So episode 9. And we're going to go down here to the OLED page. And you can see I have a bunch of files in here already. But I'm just going to create one called OLED test. And I'm going to say save. So there it is there, OLED test up at the top of the screen. So there's our start of our test. Well, the first thing we need to do is we need to include any helper files. So this is going to be include any required helper files. Now, there's a couple of things that we need in here. One of the things that we need anytime we want to talk on I2C on Arduino, we need to include wire. So let's do that. So we're going to go include wire.h, which should be already installed on your libraries files because that's a standard with Arduino. So we're going to have that in there. We're also going to include a couple of other files, and this is only because they're in the sample files. I thought I would include them here as well. So I'm going to go include, and I'm going to put in 2 Adafruit libraries. Now you can get these libraries just like we did before. You can go up to Tools, and you can go to Libraries, and then you can, let me just show you that at the top here. Actually, it's Sketch, and we're going to here include library, and the very top thing here, it says Manage Libraries. So if you don't already have them installed, if I come down here, I can actually go down here, and I can actually, I think it's off the page. It is. Oh no, it still shows it on there. We just made it. This is an SSD 1306 is the driver for this particular OLED. They also do an SSD 1305, which is a slightly different version. So that one's there as well. And I may have to try my other boards. Maybe I'll try it with a 1305, but I don't know if it'll work there either. But anyways, we're going to go in there. And when you do that, you'll actually get the proper helper files. The other thing we're going to be loading is this graphics library, and that allows us to do any special characters and things like that. So in case we need it, I'm just going to go ahead and add that now. So I'm going to add the Adafruit_GFX and .h. And then the other one is, of course, is the main file. Now you could just pick these off the list. I have them already installed. If you know what they are, you can just type them in. Choice is yours. Like a lot of things in life, we have choices, which is always nice. So this was the SSD 1306.h. All right, so we've done those, and those libraries are already installed. So those are all the required libraries we need. So we're going to go ahead and stay with those. Now what we're going to do is we're going to have to set up the OLED display. So we're going to have to do this here. So set up OLED display. And there's going to be some parameters we need for this. The one thing is because they come in different sizes, we're going to have to say how many pixels by how many pixels it is. So we can use define, or you can use integer, your choice. It doesn't really matter. So I'm just going to use the define key this week. So define, and I'm just going to call it width. And I'm going to set the width to 128. I'm going to use define again, and I'm going to set the height. So I might as well just call it height. And I'm going to set that to 64 to match the board that I'm using. And then something else we need to do with these, because some 1306 boards have this and some don't, and this is regardless of whether you're on Arduino or these other aftermarket boards, is that you can have a 5th pin, which is a reset pin. So all of the drivers that I've found, basically, because this can be an option, and it depends on your board, they actually include this reset pin designation. So we're going to assign pin 4 as a reset pin. Now that means that pin 4 on our digital pins won't be usable to us because it's going to be set for the use of this. So that's going to be the pin address used for the reset, even though we don't connect any wires to it. So we're going to lose a pin. Keep that in mind when you're doing this. It's just something that it likes to use. If you use multiples of these screens, you can actually use the same reset pin on all of them. Okay, and then the final thing we need to do is actually create the driver itself, the object. This is where we normally talk about creating objects when we're adding a device. So this is going to be the Adafruit _SSD 1306, because that's the default, and it's a parameter called display. And what we have to do is, this is where we're going to define it now. So we're going to include the width, the height, We're going to include the communications protocol. So it uses the ampersand and then wire, because that's what we called it. That way it just uses the default addresses that are built in for the Arduino board. We don't have to assign any pins for it. And the last thing we're going to do here is we're going to put in OLED, as long as I type that properly. OLED reset. And there we go. I'm looking at the edge of the screen and I'm writing, falling off the edge, but that's okay. So it's a little bit wider than my page was. But basically we set up 4 parameters here. So we gave it the default name of the file, which is that we want to use the helper file, which is Adafruit SSD 1306. We're going to go after setting up the display property, so we call up the keyword display. We set the width, the height, wire, and OLED reset. If you really wanted to, you could hard code those numbers right into this line and you don't have to create variables for them. You could do that. The advantage of doing this is that now I could have multiple boards and I could actually just do the same thing over and over, and I could create multiple displays. So I can actually create them with slightly different addresses, and that's the other thing I can do. There is another address parameter you can put here on the end if you need it. If you need the 5th parameter, you can actually do the address. So that's where that lies right now. So we do have things that we can do, and in fact, actually, I believe the address for Arduino mostly gets set in the void setup file. So when we get there, we'll go over that. Let's see, is there anything else I need? So I'm just going to put in my header here. Let's get that over there. So this is going to be any other needed pins and variables. We're going to have to add those as well as we come across them. Now to start, we're not going to need any, but we will when we add the potentiometer in here. We're going to need to add some. So let's continue on with what we got here. Let's get into the setup now. So a couple of things I'm going to do here is I don't really need the serial monitor, so I'm not going to do that this week. So let's get rid of that line right there, and we're going to just start typing it here. So what we want to do is we want to initiate the display. Well, it's called display, so we know that much. Display.begin. So this looks a lot similar to setting up the serial monitor or any other serial device. And then we have to tell it what we're going to be starting. SSD underscore 1306. Actually, in this case here, this is all one. This is where the helper files, their example files, come in handy. Otherwise, you got to look through some documentation. And this is always really nice when you end up with things like this. So this is switch cap VCC. So that's just a parameter that they've set in there, and that's just going to tell it to run normally. And then we set the address on this one. So this is going to be the 0x3c. So there's our address in hexadecimal, 3c. Yeah, fixed line 6, include rather than include. You know what, that'll probably work a lot better. I'm sure I would find that out when I validate things. But good catch on your part, Walter. See, you're actually learning how to code. I like this. You are learning how to code. So I'm just going to put that in there. So that actually creates the, that there is, I created the object for the display up here with the Adafruit SSD 1306 display, and then set the parameters for it. And then down here is I just enable it. So I'm just saying display begin. This is their keyword that they're looking for the board, and 0x37. So this just matches up with their helper file. This is something that somebody's created. Other helper files, if you're using somebody else's other than the Adafruit SSD 1306, and there are other ones out there, you have to use their keywords, whatever keywords they've set up. So just keep that in mind when you're doing things. So now that we've created the display, the first thing we're going to want to do is we're going to want to blank the display. So we just use the word display, and we're going to hit display dot, and we're going to clear the display. And luckily the keyword for that is just clear display. And just close it into the brackets. What that's going to do is that's going to turn off all the individual pixels on that board. So that's what that's going to do. It's going to set them all to black. In other words, turn them off. Now the other thing I'm going to do here is I'm going to actually create some other things in here. I have display, and something else that we can adjust here is we can have display set text color. Now you're thinking this is monochrome. This has only got white pixels, but we can have it reverse everything so it's a white background instead of a black background, and have all the text in black or the graphics in black. And what that does is basically you have to say, hey, turn all the pixels on, and then when I write stuff to it, turn off the ones I want instead of the other way around. So that's what that does for me here. So in this case here, I'm going to set it for SSD 1306 underscore white. It'll probably work if you don't, this is all capitals. This will probably work if you don't set this, but it's safer, I find, to set this up at the beginning. There we go. That'll work much better with numbers rather than those graphic symbols. I was not swearing at it. I'm trying to be nice. SSD 1306. If you do want to reverse this, you put in SSD 1306 underscore black, comma, SSD 1306 underscore white. So you actually add the reference to black first, because this will be the text color, and then the other is the background color. If you don't specify, it goes to the default value. So now that we've done that, what I want to do is I want to write these two parameters I've just set. I want to set them out to the board itself. So to do that, I use display.display. If you remember before, we used things like show, display.show when we were doing LCDs. There's a couple of different variations, again, depending on the driver. And the only other thing I'm going to add in here is a short delay, just so it doesn't jump past it too fast. And I'm going to put in a ½ second delay. And now I have my setup file. So in this setup file, this all has to deal with the OLED screen. So we're going to go in here, we're going to say display begin. We're going to set the parameters, including the address for it. Because we could actually have something saying equals display begin. We could create another variable in front of it. That way we can have multiple displays and turn on variables. We're going to clear that display. We're going to set the color, and we're just going to tell it to go ahead and update it. So this is the updating. This updates it, so the whole screen updates at once. This way you can make a bunch of changes and then update it in a single pass. So you don't have to keep doing it as you do each little piece. So that's basically how that works in there. So now let's have a look at our main loop. Let's create a little bit of simple text just to prove what's going on. So I'm going to come down here to the text, into the void loop, and I'm going to just create something. And when we start out, one of the things we like to do is we want to be able to update everything at once. So we normally start by adding in the display, and we're going to go in here and we're just going to tell it to clear the display so that we start with a fresh screen. So there's nothing written on it ahead of time. Now, because this is not an LCD, we can actually change the size of the text. The default text size is size 1. So let's have a look at what that is. So I'm just going to put in here display dot set text size. So I'm going to set it, and I'm going to set it to a 1 just to show you the default size. The next thing I want to set in here is I want to actually put the cursor up into the top left-hand corner of the screen, which is actually position 0, 0. So there's 128 pixels going across. They are numbered from 0 to 127. Going down from the top, they start at 0 and go down to 63, giving me a total of 64 bits, or 64 pixels going down. I can pick anywhere in that grid to start my text. So I'm going to start my text in position 0, 0. So I've done this. Now I'm going to tell it where to put the cursor. So display dot set cursor, and I'm going to tell it to go to 0, 0. So now it's going to the home position. And then very simply, just like we do when we do the serial monitor, we're going to put in here display dot, and these print commands work identical to they do in everything else. So we're going to display a print. So we're going to go ahead and say, hey, display print. We're going to put in here, and we're just going to go, let's do this in quotes. Welcome to the show. So I'm not sure if that's going to fit in there. We're going to find out when we download that. And we're going to put that in there. And then what we're going to do is at the end of this, just to show you the first part, we're going to get this up and running before we create much more, is I'm going to put in a delay here so it doesn't constantly do this. So I'm going to create a delay of about 1/4 of a second, just because we don't need it to constantly write to it. We can actually, every 1/4 of a second, updating the screen is probably fine. If this is right, when I validate, it should be okay. So let's verify it. We're going to verify the sketch. It's going to compile the sketch. Let's see if it worked. Let's see if I'm okay. Did I make another typing error? Ah, no, I made another typing error. OLED reset was not declared in this scope because I reversed 2 letters here. That's why we check. How come you didn't catch that line, Walter? Hey, you missed line 12. Oh, that says test color. 1 key's above the other. Wasn't this a lot nicer to check when we only have about 30 lines of code rather than waiting until we had 50 or 60 lines of code? And this time it cleared. Hey, look at that. It's showing good at this point. So now that that's done, I'm going to go ahead and upload this, and we're going to see it, and we're going to see this come up on the screen now. So right here on the screen, we're going to see that update. So it's uploading, and it's going to go through its little clear, and look at that, nothing happened. Oh, why didn't it happen? Something happened that I broke it. Okay, so let me, that's a possibility. What didn't I set in here? I may not have set something. Let's go over my program. So before we got any further, I'm glad we checked this because we just showed blank on the screen. And that's not what we did here. Oh, you know what we forgot to do? Remember I talked about here we have to update the screen, tell it when to update using this display. I never included it in here. So let's go back in here and put in display bracket. This will update my screen now, just like it did up here. So with that change, I'm going to go ahead and upload it again. This time, hopefully this will update. It says it's uploading. It should be done in a moment. It is. Welcome to the show. Look at that. But look how tiny that print is. That is the default scale of the text, and it did fit. I was surprised. I knew it was going to be close, but we do have a line of text. So that gives you an idea of what we can do with that. But look how tiny that is. That's not much taller than these pins are wide. That is really tiny text. If you want to read that from a distance, you better have good eyes or good glasses. One or the other in order to read it. So we're not going to use that size of text very often. We can if we're going to be able to see it up close. If not, what we're going to do is we're going to go in here and we're going to create some more text. So what I'm going to do is I'm going to go in here and I'm going to say, hey, let's display, and I'm going to go set text size. So hopefully we're doing that right. And we're going to go to the next size and let's see how big that is. Okay, for this here, I'm going to change the cursor position. So display dot, and this is going to be set cursor. Now this is where you can actually, if you want to be smart about it, you can actually do a little math. The standard pixel in here, if I were to count that, I could actually see that's probably about, believe it or not, that's probably 7 pixels high. I think it's 7 pixels is the default. I think these are 7 by 5 squares is the basic number. They're the basic letters. So they actually are set up pretty small. So what we're going to do is I'm going to say, hey, come down here, and I'm going to leave a little bit of space. I'm going to say, go to, actually we start, when we're doing this, we're going to start with the column. So we're going to start with column 0, but we're going to go to, and in this case, we're going to go to line 10. Actually, line 9 is the 10th line in the program. So I'm leaving lots of space. Hopefully that will do it. And then we're going to put in some more text here. So let's go display dot print. And this time we'll move over the text. Actually, we're not going to move over the text. We'll do that in the next one. So we're going to set print, and we're going to put in here another message. This is size 2 text. We're going to even see if this fits. I'm not even sure if this is going to fit. And then we're going to turn around here, and what we've done here is we've basically said, we've used these 3 lines. We set the color size to 1. We move the cursor to the position we want, and we put in the welcome to show. Then we did this, and now we put in another one that says size 2 text. And when we're done, we're going to display it. So we've just done this very quick. Let's upload this and see what happens. So we're going to do this very quickly, and we need to put a T in there. This is why it's nice to build things in little blocks. It's easy to get one little fix. What did I do wrong on that one? I get talking and I miss things. And I think it's happy this time. And it is. So now it's uploading, and we should see the screen update. Oh, look at that. See, not enough room to write that line of text, so it automatically went down to the next line. But it did leave a little bit of black space between the word welcome and the S in size. So you can see that actually worked out good, moving it down just slightly. So it might be 5 by 8. I'm not sure, but we kind of left a line there, because if it's 8 high, it would have used 0 to 7. 8 would have been a blank row. We started in row 9. So we're going to shorten that text a little bit. What I'm going to do is, just because I don't want it to run over, I'm going to do that. What I'm going to do very quickly is I'm going to take these 3 lines of code and I'm going to copy them. I'm going to paste them here. That should give me less spelling errors. I'm going to go to size 3. And instead of starting in row 9, well, we just went with size 2. Size 2 is a fair bit bigger. We know we have lots of room on this screen. So let's go to like row, I don't know, 24. That's just a guess. And we're going to put in here size 3. We're going to keep it short. And we're going to update this. We're going to take a look at it, and then I'm going to add the analog so that we can actually do something practical with this. So it's uploading right now. And there we go. We can see different sizes in text. You can see it gets a fair bit larger. The text is a little bit blocky, so in the larger size, it's taking up multiple bits, each individual pixel side by side to create the letters. And in fact, 24 was probably not quite enough room. I think the S's are actually touching each other. So something to keep in mind here. But the whole thing is we were able to create a screen pretty easily. And we still got a little bit of room down on the bottom of the screen. So we haven't taken up all the space by any means. But there we go. And that last size is actually pretty easy to read. So now let's do our analog bit. Let's add our analog in here. So like I said before, I'm going to need some variables in here. And so I'm just going to make this really quick and easy. I'm going to do a copy and paste from my other program just to save a little bit of time. Also prevents errors. So here's my pot pin coming in. I've created an integer for pot pin, and it's going to be connected to A0. I'm going to take that raw value in, and I'm going to bring a percentage out so I can display it on the screen. And in order to do that, I'm going to create a little bit of code. And again, I'm just going to copy what I have here. I'm going to come down here to my loop. I'm going to go to the beginning of my loop. and I'm going to paste that in there, and I'm going to go over what's in here. So it says here, the first line is to read the raw input from the pot. So I'm going to have raw in going to analog read pot pin, which is A0. So it's just going to go and grab that information off of that pin. Then it's going to convert the raw into a map value. So it's going to take the percent is what my variable is going to be. I'm going to map the variable raw in. So don't forget, raw in on Arduino comes in from 0 to 1023. So what I need to do is I need to take that scale from 0 to 1023 and I need to remap that as a percentage. So I want to map it from 0 to 100 for percent. And I'm going to include that down here. Now what I'm going to do is I've already figured out some stuff before, so I'm going to modify my printing code down here. So I'm going to start with size 1 is fine, 0, 0. But instead of welcome to the show, actually I'll leave it as welcome to the show because it doesn't matter. It's good where it is. But I can move it over slightly if I wanted to. There's actually space on that top line right here. I can move that over by a few pixels. So what we're going to do, instead of starting at position 0, we're going to start around position 3. So I'm going to go 0, 1, 2. We're going to be blank. And then in the 4th pixel, I'm going to do it. Pixel 4 is number 3. And then for my size 2 text, instead of starting here, I actually have it set up. I already know this works, so I'm going to go 1010. And what I'm going to do is I'm going to change the message here to volume, okay, and I'm going to put in the percent symbol. It's a text character, so it'll work fine. So I'm going to put that in here, volume percent. And then what I'm going to come down here is to the third one. I'm going to make this start out from 30, and I'm going to go over to 32. Give myself lots of room. And what I'm doing in here is I'm actually going to add one new line in here. So I'm going to add a display dot print, and I'm going to put in here the value percent because I want to actually put in that changing number on the screen. It doesn't just say much if we're just going to have a static information on that screen. We'd like it to be able to change. So we're going to add that. And on the next line here, instead of saying size 3, I'm just going to put in the percent symbol. Right there like that. So there's my new message that I'm going to send out to the screen. If this works, we're good. So we're going to find out. It's not present, it's percent. And it wouldn't be spelled right for present either, but it says it's uploading now. So here we go. And when we do that, we're going to see there's our volume. So it says, welcome to the show, volume in percent. Now, as I turn this dial, you can see I now have live data coming through all the way up when it's maxed out to 100%. And then I can bring it back down here. So I could have this as a volume control, and this would be my feedback to tell me, oh, okay, I'm set at roughly 38% of the volume. So I'm actually able to do something practical with it. And you could actually have other information coming up on the screen. We could have the screen updating at various rates. But you can see right away that we're actually able to create live information all the time. So it's here, we've got it in multiple different text sizes on the same screen. I've done it, so now my numbers that are the important part to me are big. The rest of it is filler text. And we can actually create variable things on the screen so that it's very easy to read. And it is actually quite large. It's actually very large, nice and clear in display in real life. So hopefully that works. I'm going to say right now. You can do a lot more with this text. When I had that sample file in before, you could see that the screen, the text will actually scroll from left to right, right to left. It'll blink, it'll do all kinds of things. It'll do all the same stuff that we were able to do with the LCD display and then more. And that's just the advantage of having an OLED screen. Nice, clean image, not hard on the eyes. You can actually get these in different colors if you'd rather have, you can have blue text, white text, yellow text. Some are even, the first so many lines are yellow and the rest is green. You can buy different versions of it and have specialties. So you can have the first 10 rows are maybe yellow. And there are ones that are made, and they don't change much in price for the different variations, but it's nice and small, and you can hide that, and it doesn't take up much space. So that's how that works. Now we're going to have a look. Hopefully that answers some questions. Hopefully you'll find that interesting. It's a nice, simple thing to do. And I want to go over, before we run out of time on our show, we haven't got a lot of time. We're only going to do about another 10 minutes. And I want to talk about the CircuitPython version of this. So let me move this one out of the way. Let me bring this one in. And in fact, actually, I'm going to bring that right into here so that we have that on there. I'm going to open up my Muse screen to show you the coding for this one. So this here is the coding for CircuitPython. So this is what's actually running on that board. As you can see, there's a whole bunch of writing on there, but I'm actually going through a bunch of different things. And you can see that it's running through a sample file right now. And what I've done is I've taken that basic sample file and cleaned it up for use in here. And I'm going to talk about the code that's required now for CircuitPython. It's still pretty simple, a little bit different, but that's okay. So this is what they refer to as frame buff test. And this was by Adafruit, and I've just modified it. And this is done on the Adafruit M4 Express, is the one I'm using with CircuitPython 5.3.0. They're actually getting close to releasing 5.4.0, I believe, or no, 6.0. They're making some energy savings and things like that, so you can put the chip to sleep. They're still developing the language quite a bit, so there's updates coming shortly. Again, I start with my helper files, just in the same format as I did on Arduino. So I import time, board, bus IO. Bus IO is used for the communications, so we need to have that there. Digital IO, import digital IO. I'm going to have digital in out. I'm going to need that because I need to have that reset pin, just like we did before on Arduino. It needs to be set here as well. And then the last thing is I'm going to import the Adafruit SSD 1306 file. Similar to what we had in there. In our case, we just make sure we add it to the library folder, the LIB folder on the drive, on the memory chip that's on here, whereas we had to do an include in the other one, and it actually writes it into memory. So the next thing we do here is we create the communications port, I2C. It's bus IO, so there's that bus IO that we're using, .I2C, and we're just using the boards, our pre-assigned SCL and SDA. If you look up those numbers, you can actually substitute those in with the other numbers, but it's done automatically for you. It's already been pre-assigned. The other thing we're going to need to do is we're going to have to add this reset pin. So here's that reset pin is going to equal digital in out board board D5. Now we didn't have to do anything to it or anything else. It just needs that one line of code in there. And even though we're not using it, now D5 is not going to be usable for anything else because it's going to have this reset function built into it. The next thing I need to do is I need to create the object just like we did before. So this is the object called display, and it's going to use the Adafruit SSD 1306 file. Inside of that, it's going to use the SSD 1306 I2C protocol. Now over here, I'm just going to do this because I'm going to need to scroll across. Again, what I've done, and this is showing you all this whole line here. So the parameters in here, just like we talked about in the other one, we had the reset pin in this place. We only had the width, the height, the I2C protocol, the address in this case, and then what the reset pin is connected to. So reset is equal to reset pin. So that would be the other one that would be in here. This one would not be in the object when we did this in Arduino. It was done in the void setup file. This one you do it when you create the object initially. So that's what that is. So just to let you know. Then it has here print pixel test. I just have that so I can bring that up on my serial monitor and I can see that going by when it first loads in, just to show me that it's what it's doing. Then what I've done is I've gone in here and used a display.fill. You'll remember this type of thing when we were doing the fill command, when we were doing neopixels. This is very similar. And then we use the display.show. Display is our object, don't forget. That's where that name comes from. This could just as easily have been something other than display. It could have been OLED. It could have been whatever we wanted to call it. So this one here clears the display, so it actually sets all the pixels off by setting them to 0. And then what it does, it says here show, which is just updating the display. So that's similar to that display.display bracket that we used in Arduino. Now, I've created a bunch of subroutines here. There's one here for creating the dots. When this sample first starts, you get 3 dots, and the 3 dots are located, what it is, it's in column 0, row 0, set it to a value of 1. And then what it does here, it actually does the calculations based on the width and says put it halfway across the page, so at number 64. So what's going to be, it's going to be at 0, 64. It's going to, or actually, there's height and width calculations. So what they're going to do is they're going to actually move all the way over and then back up 1. So it's actually going to go at, instead of 128 divided by 2 would be 50, what is that, 64? Minus 1 is 63, so it's actually going to be at 63.31 and set to 1. And then the last dot is going to be put down at the very bottom right-hand corner, which would be 127, 63, and then 1 to set it to a pixel brightness of 1. 1 being true, you want to turn that pixel on, the other one off. Just after we're at where we are right now on this display, you're going to see the text. There's the 3 dots on the screen. They were there drawn, and then it started doing the next one. Lines, we actually do some math, and we're actually drawing the squares. This is why it's important to set those parameters up properly. If I put the narrow display on here, what would happen, instead of being all as high as they are, my height would only be 32, and everything would adjust accordingly, because this is just math. So that's what that does. We create some rectangles in there. We also create a bunch of text. This is where I created my text screen. So what I did here is, this is done in a single line as opposed to multiple lines like it is in the Arduino. Here I just tell it to display for the object dot text, and I give it what text I want, and then where do I want it to be positioned. So I do the not only writing the text, but I also set the cursor position at the same time. So that's what all this is doing here. And I've actually taken some time to center it up so it's fairly well in the center of the screen. And basically this was microcontrollers with kingernorth, episode 15, using OLEDs with, it should say, actually it should say OLED display. So we can actually change that. Why don't we see how that works out? That was what I was going to name the show. So I'm going to put it there. Looks like it's going to be in the same spot. It's about the same width. OLED display with CircuitPython and Arduino. So if I did all this right, it's going to be here. I am going to show you something a little bit different in this. I want to talk about. Here's display show. So it's going to update that. It's going to sleep. And then what it's going to do, it's going to go here to set it to 0. This is where it comes out a little bit different, is we have characters. So by default, there is a default text font built into the driver. And this happens to be a small one, and we're going to get to that line in a moment. But you can, to change character sizes, you actually import, can I use this to calibrate my block occupancy parameters without a computer hookup? You could, but then you'd be leaving a display hooked up. Because I2C doesn't like to be disconnected while it's running. So you could hook it up, you could have it, and if you wanted to leave it that way, you could leave it that way. So that is another option, and you can actually have it print up on a screen what's going on your block occupancy detector. So you could add that. It just adds another little feature to it, and it could be convenient for you, because you can actually create text rather than having a bunch of LEDs even, and saying which lines are occupied, which lines are not. You could create that. That'd be interesting. Here, let's go back to here. So my character size is going to be 6 by 8. Characters just per line is going to be basically the width divided by 6. And it does the calculation here and figures it all out. Now, there's something it shows me here. It says it's missing a file. If for some reason it can't find the text file, so I'm going to move this over so I can get to the end of the line. Because here it tells me the file. So if you're doing frame buff, you need to have the file called font 5x8 bin loaded in. And yes, you could do you can put that file in there, and it just goes into the C drive or G drive or whatever letter it happens to be. It won't be C because that's usually your computer hard drive. But you're going to put it in the same place where you put your main program, which is just code.py. So you're just going to put it in there. And you can have multiple bin files, font files. And these are custom fonts, and then you can use them accordingly because you can change fonts while you're doing this. So you can have different size text. So that's how they do it in theirs. So we just got to keep that in mind when we're doing things. And then we tell it to sleep. So what does our program look like? This is it. This is the whole program right here. It's really short. While true, I'm just calling each of those subroutines. Each one of these defines up here is a subroutine. So I have one called text, one called rectangle, one called lines, one called dots. So when I scroll through all of this, I say, hey, run dots, then run lines, run rectangle, run text, and then I tell it to clear the display and update it. And it just does that. All the timing features are all built into each one of the subroutines for itself. And you can see that we have lots here. So when we're scrolling through on this screen here, if you watch down here, when we get there, there's the big line, all the text. If you want to see all the different characters that are available in that subset, there they are there. I have to set the time longer. I haven't updated this yet. It says using OLEDs. So let's save this. I'm going to turn on my serial monitor up here. We can see that it's talking to it. I'm going to hit save. And that fast it updated. That's one of the advantages of this over Arduino. This is a very fast update. And now it says OLED display with CircuitPython and Arduino. So when we get back to the text, there it is there. OLED display. So it took that text change that I made. So very quickly, that's the advantage with CircuitPython, is that it's very fast to do development. For me to align these lines, I was able to make lots of little changes and just keep updating the file. And every time I updated it, it just booted up right away. Very quick and easy. Yeah, by all means, get creative. Like Walter's getting creative. Walter wants to actually take some infrared detectors or some, in his case, he's using LDRs, the light dependent resistors that we talked about way back. And he's taking those, he's taking information from that. He's got pots that he's been able to do. He's got NeoPixels that he's been programming to work with that based on whether they're blocked or not. Now he's looking at adding an OLED screen possibly. And he can have graphics and text printed out. So he could have lines showing which ones are full with the number of the track in front of it, for instance. You can see I have 6 lines of text on there. And I think I have room for 7 lines of text in there. So if you had 4 tracks, you can easily put 1, 2, 3, 4 on it and just show a line or no line, whether it's empty or full. Maybe use dashes if it's empty. Use a solid line that could be 3 pixels wide because you can set custom characters. Remember, we were able to do the special characters in the sample file that ran for Arduino. Well, you can create special characters in CircuitPython. You can also use math to draw the lines. So you could actually draw a line that's 3 pixels high by 80 pixels wide. So you could draw that on the page and tell it where to write it. Because we're using math all over the place to write these samples right now in CircuitPython. You can do that in Arduino as well. So lots and lots of things you can play with. Lots of different graphics you can create. You can certainly have fun with this. This is the idea with this, is you learn, you play. When you build one thing, you try it, and then you come up with something else built off of that same idea. So here's some ideas for you. So you got an OLED screen now. OLEDs are really handy. If you want to be able to do quick editing, go to CircuitPython. If you want to go to something that's really stable, has been around a long time, use the Arduino. Both are relatively inexpensive. Both are easy to use. And it's just a matter of getting preference on how you like to write your programs. There's not one program that's true for every application. Some are better for some things. Others are better for others. So I guess that takes care of it for today. I hope you enjoyed this talk. This was OLED Displays with CircuitPython and Arduino. I'm your host, kingernorth. I hope you enjoyed everything today. We're going to be shutting this down, and we're going to be saying this is our closing. So thank you very much for watching this, taking the time to watch this. This was actually one of our slightly longer episodes today. I think this one's just over an hour, but not too bad. Remember, if you want to get notices about this, you can follow me on Twitter at kingernorth. You can also subscribe and get notices from YouTube. I put these shows up. I try to give you a 24-hour notice to tell you, hey, there's another live stream coming up. You'll also get notices then if I post a new video up or I put up an edited video. You'll get notices of that as well. So youtube.com/kingernorth. Just remember to subscribe and set up the notifications. And that's all I've got for this week. So thanks very much for showing up. You are the people that make it happen. I love getting those comments inside of my previous messages or my previous videos. People that have attached comments. Tell your friends, tell other people that you know that are involved in electronics, model railroading, or just interested in microcontrollers in general. Let them know about this, and we'll continue on. I'll be back next week with another topic. I've kind of got something in mind. I'm just going to play around with it. But if you subscribe, you'll get the notification ahead of time, and you'll know what the topic is. Thanks. Have yourself a great weekend.